Alright, our last video for today, Thursday, I guess October 13th, is on solving quadratics by taking square roots. Solving by taking square roots. Okay, so I posted two other videos on simplifying radicals and rationalizing radicals. Now those are just skills that help us take square roots. So after we take square roots, we might have to simplify, we might have to rationalize a radical. But this is the key lesson. We want to be able to solve a quadratic, and the method today is by taking square roots. So here's an example of what that looks like. 3x squared plus 5 equals 41. Now, we can solve this by taking square roots because notice we only have one x squared term. If we had an x term as well, we couldn't solve by taking square roots. So if this was 3x squared plus 2x plus 5, we could not solve by taking square roots. But because there's only one term here with an x, we can solve by taking square roots. Okay, so how do we do this? We first need to isolate x squared. So just like algebra 1, I'm going to move this 5, and then I'm going to divide by 3. So now I've got x squared by itself. So x squared equals 12. So this is saying what number squared is 12? What number squared is 12? Well, to undo this squared to get x by itself, we take the square root. Now the square root of x squared is saying what number times itself is x squared? Well, x. And then we have the square root of 12. Now here's an important thing. When we solve by taking square roots, we have two solutions, both positive and negative square root of 12. Let's talk a little bit about why that is. So remember in this last step we had x squared equals 12. So we had to ask, like, what number times itself is 12? Well, there's both a positive and negative version to that answer. A positive times a positive is going to be positive. A negative times a negative is going to be positive. Let me kind of do another example over here so you can see that. So if I had x squared equals 9, there's two answers to this. What number squared is 9? Well, 3, because 3 times 3 is 9, and negative 3, because negative 3 times negative 3 is also 9. So when we solve by taking square roots, we have two solutions, plus and minus 3 in this case. Anytime we solve by taking square roots, we need to write plus or minus. Okay, graphically, we can verify this. If I were to graph this equation, so if I were to put this into my graphing calculator, I would need to get 3x squared minus 36 equals 0. If you want to graph, you need to put it in standard form, meaning we need to get all the terms on one side. So I had to subtract 41 from 5. So I get 3x squared minus 36. If I graph this, notice that there's two x-intercepts, one here and one here. Both, I have positive 3 point something and negative 3 point something. Well, that 3 point something is the square root of 12. The square root of 12 is 3 point something. Let's see what it is. The square root of 12, square root of 12, yep, is 3.46. So x is both positive and negative 3.46. But to be exact, we're going to just simplify this radical. Square root of 12 can be written as the square root of 4 times the square root of 3. So this is plus or minus 2 square root of 3. 2 times the square root of 3 is 3.4641016514. This is the exact answer. There's two solutions, positive 2 square root of 3 and negative 2 square root of 3. Let's do another one. 5x squared equals 80. So I need to get x squared by itself, so I'm going to divide by 5. 80 divided by 5 is 16. I take the square root of both sides, so I get x equals plus or minus 4. So that was nice. The square root of 16 is a nice whole number 4. So two answers, positive 4 and negative 4. Okay, let's do another one. Let's do this one here. 1/5 z plus 3 squared equals 7. Alright, this I can solve by taking square roots because notice there's only one z. So what I'm going to do is I need to get this z by itself. I need to work outside in, so first I'm going to get rid of 1/5. I can get rid of 1/5 by multiplying both sides by 5. 5 times 1/5 is 1. So I've got z plus 3 all squared equals 35. We keep working outside in, trying to get z by itself, so I need to undo this squared. And we know now that to undo a square, I take the square root. So what number times itself is z plus 3 squared? Z plus 3. It undoes the squared. Equals plus or minus the square root of 35. Do not forget to write plus or minus. So then finally I subtract 3 from both sides. So z equals, and we typically write the whole number first, followed by the radical. So we have two solutions. We have negative 3 plus the square root of 35 and negative 3 minus the square root of 35. These are my two solutions. And of course you can pause to look over what I just did, but I'm going to move on to number 4. We'll do one more of these. So if I have 3 times the quantity x minus 2 squared equals 40, I can solve this by taking square roots because I just have one x term. We work outside in, trying to get x by itself, so first I need to undo multiplication by 3. So I divide by 3. So I have x minus 2 all squared equals 40 divided by 3. Let's see, 40 divided by 3 cannot be simplified, so it's just 40 over 3. And now I'll take the square root of both sides to undo the squared. So this is x minus 2 equals plus or minus the square root of 40/3. Finally I add 2 to both sides. So x equals 2 plus or minus the square root of 40/3. That is the answer. However, we want to simplify, or in this case I should say rationalize. Because I have a fraction in the denominator, I know that I need to rationalize this. So this is x equals 2 plus or minus the square root of 40 over the square root of 3. And so I multiply by square root of 3 over square root of 3. We learned this in a previous video. So x is 2 plus or minus the square root of 40 times 3 is 120 over square root of 3 times the square root of 3 is the square root of 9. So x equals 2 plus or minus, okay, the square root of 120, I can simplify that. Let's see, 120, let's see if it's divisible by any perfect squares. Let's start with a big one like 64, no. 36, no. Sorry, 120 divided by 36, no. 120 divided by, what's another, maybe 16? No. But it's definitely divisible by 4, I know that. There we go. So this is the square root of 4 times the square root of 30 over The square root of 9 is 3. So x equals 2 plus or minus the square root of 4 is 2. Root 30 over 3. And so this here is our final answer.